Here's a classic age-based problem that we usually solve with algebra. I'm going to show you two ways to solve this problem without using algebra. So here's the problem. 5 years ago, Lucy's age was 3 times Max's age. In 2 years, Lucy's age will be 2 times Max's age. How old is Max now in years? Now, at first glance, this seems pretty confusing. If we were using algebra, we would create some variables and make a couple equations and substitute and solve. But how do we do that if we have a student who doesn't know how to do algebra yet? Well, there are other ways to solve this problem. So strategy 1 is we're going to try and use something called the bar model. It's kind of a visual way of doing algebra. So there's a little bit of complexity here, and I'm going to simplify it for myself. I'm going to start off by thinking about what 5 years ago as kind of my base time frame. And so I'm going to have Lucy's age 5 years ago and Max's age 5 years ago kind of be the reference for my whole problem. And I'm just going to draw a bar to represent Max's age 5 years ago. So this is Max 5 years ago. Okay? And we just imagine the length of that bar to sort of represent Max's age. The longer it gets, the older he is. The shorter it gets, the younger he is. What we know, what's given to us as 3 of these, Max 5 years ago, is equal to 1 Lucy. So I could draw a Max and another Max. And I'm going to label them M, M, and a third one. And this, whatever this is, would be Lucy's age. So we're going to make Lucy blue. So this whole thing represents Lucy 5 years ago. Okay, everything I do over here we're going to think about as 5 years ago. Okay, that's the first statement, just represented with a bar model type of picture. 3 Maxes equals 1 Lucy. Now I'm going to draw another picture of what happens 2 years from now. Lucy's age will be 2 times Max's age. So let's see what that would look like. So what is Max going to look like 2 years from now? Well, 2 years from now, right? 2 years from now. That's a difference of 7 years. So 7 years is going to go by between this picture and the one I'm about to draw. So Max, I'm going to still use that same Max 5 years ago bar, but I need to add on to it 7 years, right? That's how old Max is 2 years from now. And we know that 2 of these is equal to what Lucy will be. So I can put another Max and another 7. And that should be Lucy's age 2 years from now, right? So 2 pictures. How is this going to help me solve the problem? Well, there's one more thing I know, which is that this Lucy 5 years ago and this Lucy now have a difference of 7, right? 7 years has gone by. We got that plus 7. So I can take this bar and add 7 to it, and it should be equal to this bar. So now I can draw this picture 7 years later. So we have 3 Maxes and a 7. Right? Remember this part is Lucy 7 years ago, and the whole thing is Lucy now. And these are equal. This and this are equal. So I should have drawn them to be the same length. And they're pretty close. My picture doesn't have to be perfect. Okay, these are equal. Well, now we can look at them. And remember, each of these Maxes are equal because that's Max's age 5 years ago. So in a sense, this Max is the same as this Max. So we can kind of think about it as this one balances out with that one. And this max here is the same as this max. Okay, now I have a 7 that balances out with this 7. And what I'm left with is that 7 equals max. So that is part of the solution to the problem. Now, we have to be careful because the way I defined in my variable this little bar, the max bar, Max's age 5 years ago. So how old is Max now? Well, this is Max was 7 years old 5 years ago. So Max is now Max is 12. Okay? There is another way to solve this problem, and that way is just to make a table. So I made myself a table, and what I'm going to do is start with Max's age and Lucy's age 5 years ago. So I'm going to label these two columns 5 years ago. Okay? One of the tricky parts of this problem is the fact that it starts 5 years ago and then wants us to think about what happens 2 years from now. So for me, making 5 years ago the kind of the reference for the table makes the most sense. And then I'll do their ages again 2 years from now. And we'll label those columns. That'll be Max's age 2 years from now and Lucy's age 2 years from now. And then we're just going to guess. We're going to use the rules that we know. So Lucy's age was 3 times Max's age. So whatever I put in for Max, I'm going to multiply by 3 to get Lucy's age. And then as I go from the 5 years ago columns to the 2 years from now columns, I'm going to add 7 years. Okay, so let's make a guess. I don't know. Let's start with Max equals 10. That means Lucy has to be 30. That would satisfy the first condition. Then, Max 2 years from now, I know I add 7, so that becomes 17. And I add 7 to Lucy, and that's 37. And then I'm going to check. In 2 years, Lucy's age will be 2 times Max's age. So we're going to check to see, is this times 2, question mark, right? And the answer here is 17 times 2 is 34. So this is close, but not correct. So that's not right. They're a little bit too far apart. So I'm going to try a smaller age for Max. That will make Lucy 27. I add 7 to both. I get 16 and 34. And 16 times 2 is 32. You can see I'm getting closer, but I'm not quite there yet. 7 and 21, 14 and 28. And sure enough, that's correct. 14 times 2 is 28. So now I know that 5 years ago, Max was 7. Right? 5 years ago, Max was 7. And so the answer for how old is Max now is 7 plus 5 equals 12. So Max is now 12.